Hello everyone, I'm Nanti Kumar Singh. I'm a student in the MSc program. Today I'm going to present assignment 1 for the Body Wireless Network Technologies. In this presentation, I will explain the OSI model, TCP/IP models, signals, modulation, multiplexing methods, and finally, I will explain data link layer protocols. Let me start with OSI model. OSI stands for Open System Interconnection Model. It is a model that explains how data moves from one computer to another through a network. The OSI model has 7 layers. Each layer has a specific job. The 7 layers are application, presentation, session, transport, network, data linking, finally physical layer. Now, I will briefly explain each layer. The physical layer sends raw bytes through cables or wireless signals. The data link layer creates frames and MAC addresses. It also checks errors. The network layer finds the best path to send data. It uses IP addresses. The transport layer makes sure data is delivered correctly from one device to another. The session layer manages communications between two devices. The presentation layer changes data format and it can encrypt or compress data. The final one is application layer that gives services to users like web browsing and email. The OSI model helps us understand and troubleshoot network easily. Now let's move to the TCP/IP models. The TCP/IP model is the model used in the real internet. It has 4 layers. Those are application, transport, internet, network accesses. The application layer gives services to users. The transport layer uses two main protocols, TCP and UDP. TCP is reliable. It checks errors and makes sure data arrives in order. UDP is faster but does not check errors. It is used for video calls and streaming. The internet layer use IP addresses to send data between networks. The network access layer handles physical transmission. The TCP/IP model is similar than the OSI model and is widely used today. Now I will explain signals and data. Data is the information we want to send. For example, it may be a text, images, or videos. A signal is how that data travels through the network. It can be electrical signals or radio waves. There are two types of signals, analog and digital. Analog signals are continuous waves. They can take many values and are sensitive to noises. Digital signals use only 0 and 1. They are more reliable and easier to control. The sinusoidal signals has 3 main properties. Amplitude, signal is strength, frequency, how many circles per second, phase, positions of the wave. These properties are important in modulation. Let's talk about modulation. Modulation means changing a signal so it can traverse long distance. We use high frequency carrier signals and combine it with our data signal. Modulation is important because it allows distance communication. It makes wireless communications possible. It reduces antenna size. There are four common digital modulation methods. ASK changes the amplitude of the signal. FSK changes the frequency. PSK changes the phase. QAM changes the both amplitude and phase. It gives high data is quick. QAM is used in Wi-Fi and modern mobile networks. Now let's discuss multiplexing. Multiplexing means sending many signals using one communication channel. FDM divides the channel into different frequencies. TDM divides the channel into different time slots. OFDM uses many small frequencies that overlap but don't interfere. OFDM is used in Wi-Fi and 4G networks because it supports high data speed. Now I will explain multi-access technologies. Multi-access allows many users to share the same wireless medium. FDMA gives each user different frequency. TDMA gives each user a different time slot. Of OFDMA gives a small part of frequency to users dynamically. These methods are used in mobile communication systems. Now let's talk about MAC protocols. CSNACD is used in wired Ethernet networks. Before sending data, the device checks if the channel is free. If collisions happen, it stops and tries again after waiting. CSMA-CA is used in wireless network. It tries to avoid collisions before sending data. It sends the request signal first and waits for permissions before transmitting. Because wireless networks cannot easily detect collisions, they use avoidance. Finally, I will explain frame structure. Ethernet and Wi-Fi frames. An Ethernet frame includes destination MAC addresses, source MAC addresses, data, and error checking field. A Wi-Fi framework has more fields. It includes extra addresses field like control information. Wi-Fi frames supports wireless communications and device mode. In conclusion, the OSI and TCP/IP models explain how data moves in networks. Modulation allows wireless communication. Multiplexing and multiple access help many users to share bandwidth. MAC protocols manage communication to wired and wireless networks. This is the end of today's topic. Thank you for listening.